Morning second years, we're going to go through the solutions of the exam paper questions that I put up for you to look at yesterday. And as I said when we had our Google Meet, it's okay if you didn't get to them yesterday, that you can start to look at them today. So the questions that come up on the exam papers are often different to what we might have experienced for homework. And they're a bit difficult to predict what they're going to be. We don't have a list, and they often will cross more than one topic as well. So the very first question we're looking at here does involve coordinate geometry, but it also involves probability. Now, I know we haven't done probability since first year, but in first year you did learn that the probability of something happening, the probability of an event taking place, is the number of matching outcomes divided by the total number of outcomes. So that's just a quick reminder of how we calculate probability. So for example, if I roll a 6-sided die, the probability that it lands on the number 3 is 1 in 6. There's 1 3 out of the total number, which is 6. So let's look at this question here. We have a coordinate diagram below, and 16 points are marked with a dot, which are shown here. So 4 across and 4 down. Louise picks 1 point at random from the 16 points that are marked here, and she finds the equation of the line that goes through this point and through 0, 0. Okay, so she picks a point. For example, she might pick this point, and she'll pick the point 0, 0, and she's finding the equation of the line that goes through those 2 points. The question here is to find the probability that the line that Louise picks has a slope that is greater than 1. So let's look at the different kinds of lines that she could draw. She could have picked, for example, this point up here, just as an example. So she could have done the equation of this line, or she could have picked maybe this point over here. So she would have had a line looking like this, or she could have picked maybe a point over here, and she would have ended up with a line like this. Okay, those aren't all the lines that she could draw. She could have gone through any of the 16 points there as her second point with 0, 0. The question here, though, asks us to find the probability that it has a slope greater than 1. Well, if we're going to look at a slope greater than 1, it might be useful to look at what a slope equal to 1 looks like. Slope equal to 1 means that rise over run is equal to 1, which means you go up the same distance as you go over. So we haven't talked in detail about what exactly a slope of 1 looks like, but for example, if I'm starting at 0, 0, if I go up 1 space, I must go over 1 space. If I go up 2 spaces, I must go over 2 spaces, and so on. So rise over run equal to each other would be all the points along this line here. Now, all lines are straight lines, but sometimes we tend to refer to a line like this as being straight because it's going through the diagonal. I've got the same number of points either side. But in any case, this is the line. I'll draw that a bit better. But this is the line where, for each of these points back to 0, 0, the rise is equal to the run, which means we have a slope equal to 1. So then, what does it mean for the slope to be bigger than 1? It means that, so if the slope is bigger than 1, it means that the rise is bigger than the run. That's one way of thinking about it. But also, when the slope is bigger than 1, the lines are steeper than the green line I drew above. You wouldn't have to write down this explanation or anything like that. I'm just doing it here for us to understand. So basically, this line would have a slope less than 1, and this line would have a slope bigger than 1, because this one is steeper than my green line, this one is less steep than my green line. So any of these points here, together with 0, 0, are going to give me a slope bigger than 1. Okay, so the purple points that I circled up there, and there's 6 of them, the 6 circled points give a slope greater than 1. So the probability that the slope is bigger than 1 is going to be 6 out of 16, which we would be expected to simplify to 3 out of 8. In some ways, that was a very simple question, but in lots of ways it was really complicated. So this is what I was saying when I told you you would need to think about these questions, that they're different from what we've looked at before. Now, part B then is a bit more familiar maybe. How many of the 16 points are a distance of exactly 5 units from 0, 0? Well, if it's going to be a distance of 5 units, again, we need to start thinking about this. To be exactly a distance of 5 units away, we might use our distance formula. So the distance formula is the square root of the difference between the x values squared plus the difference between the y values squared. How would we answer a question like this? We might have to, would we work out the distance formula for each of the points? Well, we could, but we can be a little bit smart about it as well. We're fairly sure that this one's less than 5, right? This one, this is the point 2, 2. Well, let's check it, okay? So let's go along the diagonal first of all, and then we can start to look at other points that might give us 5. So if I look at 0, 0 to 2, 2, and I'll label that x1, y1, x2, y2, I fill into my formula, and I will get that my distance back to the origin is the square root of 2 minus 0 squared plus 2 minus 0 squared, which is the square root of 4 plus 4, which is the square root of 8. And if you put that into your calculator to see if it's definitely not exactly 5 anyway, you'll get 2 root 2. So it's 4 point something, I think. So that's definitely not equal to 5, but more importantly, it's less than 5. What square root would I need to get exactly 5? Exactly 5 means I'm looking for the square root of 25. The other thing I might notice is that I'm always going back to 0, 0. So whatever the two numbers, whatever the coordinates are, when I square them, when I square and add the coordinates of the points, I must get 25. So anyway, we know that it's going to be more than this. What about 3, 3? So the square root of 3 minus 0 squared plus 3 minus 0 squared, the square root of 18. That's less than 5 because it's the square root of something less than 25. So that's less than 5. What about 4, 4? 4 squared plus 4 squared gives me the square root of 32, and that's bigger than 5. Okay, so here's my point 3, 3, back to my diagram. Here's my point 4, 4, and I know that I can get rid of anything that is closer to the origin than that, okay? Is this closer? No, it's further. Is this closer? Maybe we can't tell, but we might just check. these points that are left over here. So we can rule out that, we just checked it. So let's check these points here. Okay, so what about the point 3, 4? It would be nice to have had a bit more room for working out, but you might do a lot of this on your calculator. So this would be the square root of 3 minus 0 squared plus 4 minus 0 squared, and that is the square root of 25, which is 5. So that's one of my points. Gives me exactly 5. 3, 4. Which means that these guys, I hope you can tell, are closer. So we're going to be able to discount them. You can check them yourself. The point 2, 4 and the point 1, 4 will be less than 25. Similarly with these guys here. But this one, the point 4, 3, is going to give me the same answer. The square root of 4 squared plus 3 squared, which is the square root of 25, which is 5. So my answer here is that there are 2 points, and those 2 points are 3, 4 and 4, 3 are exactly 5 units from 0, 0. Okay, let's take a look back now at this question again. They were saying the suggested time for this question was 5 minutes. And we know that I've spent, nearly 12 minutes talking about it, but it's one of those questions when you're sitting down to do it, you wouldn't have to write down all of this explanation. This explanation is helping you think about how we got there and how you might work it out. When you're actually doing it, you'd probably write down the answer fairly quickly, just in a minute or two. Okay, I'm going to do a different video for the other questions now, next. Okay, thank you.